This is section 523. We're going to take a look at a few polynomial theorems. So we're going to discuss the remainder theorem and discuss the factor theorem. So the remainder theorem is going to be, suppose P is a polynomial of degree at least 1 and C is a real number. When you divide that polynomial by a linear factor of x minus c, the remainder is the same as if you just plugged in that value c. So if you divide by x minus c, or you plug in c, the remainder is going to be the same. And we're going to evaluate that here in this next example. So, so let's just say this is c. C is negative 4. So I can either x minus c, which is x minus negative 4, or I could plug in negative 4, and let's see what happens. So if I divide by negative 4, I'll use synthetic division since it's a little quicker. Add straight down, multiply, add, multiply, add. So my remainder is 0. Now let's take a look at if I plugged in negative 4. So this is 16 minus 28 plus 12. That's going to be negative 12, and you get 0. Those are the same. And so that's basically what the remainder theorem is trying to tell us. Now, why do we need this? It might be a quick way for us to be able to find zeros. Like that's essentially what it is, because it might be a little quicker to evaluate than it is to divide a bunch of times. Now, you eventually will still have to evaluate, or divide, but it's just a quicker thing that you could probably practice or use. Next is the factor theorem, and this one is important because it leads us to a few conclusions. So the factor theorem says, suppose P is a non-zero polynomial, the real number C is a 0 of P if and only if x minus c is also a factor. Now, what is this implying? It's implying that if I know it's a 0, I can write it as a factor. It can state a 0 from a factor. And then I can use zeros to divide my polynomial written as x minus c. Now, this is fundamentally important, because we will then be able to, by the factor theorem, we would then be able to take a polynomial, we're going to be able to factor it, and what we use to factor the polynomial are going to be the zeros. So taking a look at this one, find P of negative 2 using the remainder theorem. So if I plug in negative 2, this is 2 times negative 8 plus 10. So this is negative 16 plus 10, so that's negative 6. So you get negative 3. So now it says use the fact that x equals 1 is a 0 to factor the polynomial. So what this is saying is, if I know that that's a 0, that means x minus your 0, x minus c, that's the factor of this polynomial. So let's go through and do it. I can divide it. So I'm going to put my 0 in the box. I don't have an x squared. You don't have to write the plus. Bring it down, multiply, add, multiply, add, multiply, add. So I verified it. My remainder is 0. But factoring it means I can now, if I want to write this backwards, constant x squared. So I'm left with 2x squared plus 2x minus 3. But now I can multiply it by what I just divided by. That's the heart of the factor theorem. And now last, some connections between zeros, factors, and graphs of polynomials. So suppose P is a polynomial function of degree n being greater than 1. The real number C is a 0 of P. Okay. P of C equals 0. x equals c is a solution to the polynomial when your function equals 0. We would write x minus c, that is a factor of your p of x, and the point p of c is an x-intercept of the graph. Now, this is just observations. There's nothing really, for us to memorize. It's just saying that, if c is a 0, that means your polynomial is going to equal 0, which means we could also say x equals c is going to be the solution to that statement of p of x equals 0. We could also write it as a factor, or we could say it as an x-intercept. That's all that this thing is pointing out. So let's look at that. You're given a polynomial and one of its zeros. Find the rest of the zeros. Okay, so this is one of my zeros, so 1. I could write out the rest, 1, negative 6, 11, negative 6. Add straight down, multiply, add straight down, multiply, add straight down, multiply. Great, see, got my remainder. So now writing it, x minus my 0, and then I get x squared minus 5x plus 6. But I'm trying to find the rest of the zeros, so that means I just need to factor this further. A times c, factors that add to b. So the zeros of the polynomial are going to be 1, 3, and 2. And so the rest of the zeros are those. And then it says factor the polynomial, so there's my factored polynomial. Now, c could also be fractions, it could be imaginary numbers, which we're going to get to eventually. But let's look at what happens when we have a fraction. It's all the same, there's just one little extra step that we have to do. So 3, 4, negative 1, negative 2. All right, so add straight down, now multiply. Now when I multiply, the 3's cancel out, so I get 2. Add, now when I multiply, so I'm going to get 4. Add straight down, multiply, so I get 2, so there's my 0. Every time you get a fraction, I just want you to know it multiplies out nicely. You're not going to get these weird zany numbers. Just, it will come out nicely. So then I get x minus c, and then what I have left is 3x squared plus 6x plus 3. Now the thing that I need to point out is it's actually improper to write x minus a fraction. C is generally an integer. So what we do, or when you go through and you divide it, whatever's in the denominator here actually can be factored out over here. So if you notice, there's a 3 in common. I could factor out that 3. Divide by 3, divide by 3, divide by 3. Then that 3 distributes into that fraction. So then you're going to get 3x minus 2. See, the fraction disappeared. And now this factors a times c, 1, factors that add to 2, 1 and 1. So the rest of the zeros are going to be negative 1, and then there's my factored form. You could also write it as x plus 1 squared. Now create a polynomial p which has the desired characteristics. The polynomial may be left in factored form. So if I know that these are my zeros, I can write it as x minus my 0, x minus my 0, x minus my 0, x minus my 0. So x minus positive 3, x minus negative 3, x minus positive 1, x minus negative 1. And then it just says the leading term is negative 10 x to the 4th. Okay, so x times x times x times x, that's x to the 4th. So it's just missing 110, negative 110. So what did we learn today? We learned a few polynomial theorems. We learned the factor theorem, which basically states that you can factor a polynomial. The factors are written as x minus c, and your remainder is going to be 0. Then we talked about the remainder theorem, which basically says if you divide your polynomial by x minus c, it's the same as if you just took c and plugged it into your polynomial. You can find the remainder in both ways. And I just both explained the remainder theorem and the factor theorem. This does conclude our lesson. If you have any other questions, please leave them in the comments.